welcome back. I'm going to share my screen. Okay, so I'm happy to still do the 55 minutes as planned. So then we will finish about 5:33, because I think everyone's quite keen to get through lots of content. Let's start by just if everybody could join the. Oh, I just realized I could hear myself through my phone. If everybody could join this Menti room, I can copy the link into the chat, or you can just go to menti.com and put in the code that is written there, which I will put back on the screen in a second. There is the link for you. And once you're in, if you could just like the page so I can just see that people are in. Okay. Cool. I've got the chat open on my phone today because that was an issue last week, so I couldn't see the chat. So hopefully, if you do use the chat, I will see it pop up if you want to alert me to anything or ask any questions as we go along. Okay, so what we're gonna do is we're gonna start with last time there was a suggestion. One of you suggested that we start each session with a practice question or two. So I'm going to give you 2 minutes on this one. And as I said last time, don't worry if you have no idea what you're doing. It's just to start to get you used to doing these kinds of questions. Okay, so 2 minutes, off you go. And obviously enter your answer on Menti. Okay, 1 more minute. Thirty seconds left. Okay, last 10 seconds. Okay, so if you're just joining us now, by the way, we're just using Menti to do this, so you can use this code to access the room. Okay, so we've got 8 people, it looks like. So the correct answer was C. So well done to those of you who got that right. So let's have a look at how to do this question. First of all, so the question says, let me get my little laser thing. Okay, so the question says, if the ratio of profit to turnover for Pacific Rim contracts was 2 to 15, what was the government turnover in the Pacific Rim in hundreds of thousands? Okay, so this is profits in this bar chart, and we've got 5 different categories. Now the question is asking about government, so we can immediately zoom in and just focus on this. And the question is asking, we've got 3 different regions. The question is asking about Pacific Rim. So we know that we want this figure. So what is this figure telling us? Well, first of all, it's in millions of pounds. So it's telling us £3.6 million. So what was £3.6 million? Well, it was Ray Heslop's consulting profits in the government part of their business in Pacific Rim. Okay, so the profit for that was 3.6 million. Now it says the ratio of profit to turnover was 2 to 15, and it asks for the turnover. So 3.6 million is 3,600,000. Yep, 5 zeros. So that's the 2 parts. We want the 15 parts. So we need to divide it by 2 to get 1 part. And then we times that by 15. And that gives us 27 million. But the question asks what it is in hundreds of thousands. So there's a bit of a trick here because they've given you data in millions of pounds and they ask you for an answer in hundreds of thousands of pounds. So if you might be able to just read that from the number, but if you're not sure, you could just divide it by 100,000. That will tell you how many hundreds of thousands it is. And you get 270. So well done if you got that right. We're going to do one more question, which I'll put on screen now. If you just joined late and you want to join the Menti room, I have shared the link in the chat as well. So just scroll up in the chat and you'll see the link there. So next question, 2 minutes, off you go. Okay, 1 more minute. About 30 seconds left. Ten seconds. Okay, so the correct answer was D. So well done to the one person who got that right. So let's have a look at this one. Okay, so what was yesterday's cost difference between 50 shares in Febs PLC and 100 shares in Deepers? So there's a lot of different data in this question, but what we want is we want to know yesterday's cost for one share, and obviously we can times that by 50 and 100 for each one, and we'll work out the cost. So it doesn't tell us yesterday's cost, but it does tell us today's cost and the percentage change from the previous day. So let's start with Febs PLC. So we know that today's price is 1,586 euros, and that is down 9% from yesterday. So that means that this amount is 91% of yesterday's price. So if we want to find yesterday's price, we need to divide this by 91%. In other words, we need to divide it by 0.91. So 1586 divided by 0.91, and that gives you yesterday's share price. Now we want 50 shares at yesterday's price, so we have to times that by 50, and we get that amount there. Now at this point, I'd probably write that down on a piece of paper, but since I'm doing it all on the screen, I'm just going to open another calculator so I don't lose that value. So Stipars is 2,537 euros today, and it's up 1% from yesterday's price. That means that this amount here is 101% of yesterday's price, 101%, which as a decimal is 1.01. So we need to divide that by 1.01, and then that will give us yesterday's price. So in other words, yesterday's price times 1.01 is this amount. So this amount divided by 1.01 is yesterday's price. And that gives us yesterday's price, and we want 100 shares of that. So times it by 100. And we get the amount for that, which is about 250,000. The other amount was about 87,000. So we want to take this amount away. So we want to subtract 87,142.857 minus 87,142.857, and we get 164,045 euros, which is D. Okay, so thanks to everybody who participated in that. What I want to do is quickly just get a bit of feedback from you. So if you were in the first webinar, so last Friday, could you tell me, did you find it much too easy, a bit too easy, about right, a bit too hard, or much too hard? And if you can't get on the Menti, just tell me in the chat on Teams. Okay, so we've got a couple of people. Anybody else wants to give their feedback? No? Okay. So one person found it much too easy. One person found it a bit too hard. So that makes me think that's not a lot of data to go on. But based on that, hopefully I'm going at about the right kind of pace. If you are somebody who's finding it much too easy, apologies, of course, I'm trying to pitch this to people who have a wide range of experience, but it is obviously going to ramp up in difficulty as we go through, but I'm just trying to take you through in a logical order. So now if you weren't here last time, oh, somebody found it much too hard in the chat. Thank you for that feedback. Okay, so what I would say, if you found it too hard, that's probably more of a problem than if you found it too easy, because if you found it too easy, obviously that's frustrating for you, but it is going to ramp up in difficulty. We're just going through everything systematically. So by the end, you will know everything you need to know. If you found it too hard, the first thing I would say is, if you actually, let me just back up a second. So if you weren't here last week, I've made this blog with a terrible URL that has loads of numbers in it, on which I'm just posting all of the resources so that you can always just access them. And also, I've also shared them on the Slack channel, which hopefully you'll all have access to. So on here, we've got syllabus and question packs. And this is like what we're going to be going through. Well, the syllabus is what we're going to be going through. The question packs are packs of questions that I've put together to help you practice the things in the syllabus. So my advice to you would be, firstly, read the syllabus notes before the webinar. Maybe even try the question pack before the webinar. And then when you come to the webinar, it won't be the first time you're seeing it. And because I am going to go through stuff fairly quickly because I want to get through quite a lot. Okay, anyway, so Last time we started looking at numbers and we looked at how to round to a certain number of decimal places. So now I'm going to show you how to round to a certain number of significant figures. So again, just make sure you've got this is syllabus section 2 open in front of you. And my suggestion would be maybe print it off or have it on a second device so you can look at it as we go through. Okay, so here are some example questions. Let me get my laser. Okay, so there's a reason why we need significant figures. And the reason is because decimal places aren't always a useful thing to round to. Let's ignore this full stop. I don't know why that's there. If you rounded all of these numbers to 2 decimal places, all of them would be 0.00, even though they're actually very different numbers. And the reason for this is because they have lots of zeros at the beginning. And when you have numbers with lots of zeros at the beginning, rounding to 2 decimal places isn't really a good method of rounding. It also isn't really a good method for really big numbers, like if you had 100,000 and 500,000 and you rounded them all to 2 decimal places, that's probably more precision than you're going to need in most situations. Okay, so instead we use what are called significant figures. So the rule for determining what is a significant figure is that any zeros at the beginning of the number, so like these zeros here, are not significant figures. And then once you get to the first digit that's not a zero, so in this case this 7 here, that digit and all the digits after it, even if they're zeros, are significant figures. So these zeros are significant, the 4 is significant, the 8 and the 3 are all significant, and anything else that came after that would be significant. But anything, the front bit that's just zeros, none of those zeros are significant. Okay, and it's important to note that although we don't usually write them, there's actually an infinite number of zeros on the end of every number, and those are also significant figures. Okay, so going back to the example questions, if we take, whoops, spoiler, if we take 3.4049, oh, I just saw Danielle said in the chat, where can I get access to the pack? So I shared it on the chat, the website. So if you just, in fact, I'll just share it again, just for convenience. And if you go to the website, this is the syllabus page, so it would just be number 2. Or if you go back to the home page, there's question packs. You just click on that. Okay, so in this case, we want to round to 3 significant figures. So the first significant figure is the 3, the next significant figure is the 4, the third significant figure is the 0. So we have to decide whether we round the 0 up or down. Well, we look at the next digit, which is a 4. So anything in the range 0 to 4 means we round down. So we just round it to 3.40. Okay, question 2, 3 significant figures again. Sorry, that's really annoying, isn't it? So these zeros at the beginning are not significant. Then we have the 3, which is significant, the 0, which is significant, because remember, any zeros after the first significant figure are significant figures. And then the 7 is the third one. Now the next digit after the 7 is a 5, so we're going to round the 7 up. So it becomes 0.00308. Okay, so round 4.96 to 2 significant figures. So the 4, the 9 and 6, they're all significant. So the first significant figure is the 4, second is the 9. We have to round the 9 up because the next digit is a 6. And hopefully you remember from last time, or if you weren't here, you might know, that when we round up a 9, obviously we have this problem that the next integer after 9 is 10, and that's a 2-digit number. So we have to make the 9 into a 0, and then we add 1 to the previous digit. So that becomes 5.0. Now we have to write 5.0. We can't just write 5. Now usually when you're writing numbers, you don't write 0.0 at the end of a number, you just write 5. But the question asks you to round it to 2 significant figures, which means your answer must be written to 2 significant figures. And if it just said 5, that would only be 1 significant figure. Okay, and this also works for numbers which don't have decimal places. So 5,873 to 2 significant figures. So the 5 and the 8 are the first 2 significant figures. The 8 we need to round up because the next digit is a 7. So it becomes 59. But then we have to stick 2 zeros on the end. So we couldn't just put 59 as the answer, because obviously the whole point of rounding is that you get something that's roughly equal to the original number, but it's just a bit simpler. So 59 would not work very well for that. So the remaining digits before the decimal place, we have to put zeros in their place. Okay, next up, calculate the difference between two numbers. Oh, sorry, that's what I was going to say before. If you are finding it difficult as well, use the Slack channel that we have, which I think Horatio just shared the link a minute ago. Yeah, he did. You can ask questions in there anytime, and I will help you out. So if you're stuck about something, have a look in there, and obviously read the notes, work through the question packs. The question packs have got answers at the back, so check the answer to the back, see if you got it right. If you got it wrong, can you figure out why you got it wrong? If you can't figure out why you got it wrong, come on the Slack channel and ask us. Okay, cool. So, oh, is it in the chat?
No, sir, I just raised my hand.
Oh, okay, sorry. Go ahead.
No, it's not to do with understanding. I'm just curious because you talked about how like if there's a number and it comes, so like with the example with the 5,000 blah blah blah, talked about how if there's like yeah, and how that if there's numbers afterwards, there's like if there's zeros after like a other number, they're significant figures. I was just wondering, like, doesn't the 5,900 like contradict that, the fact that like there is zeros at the end and they're not significant figures?
Yes, that is an excellent point that I hadn't thought of. You're right. That completely contradicts what I said. Because this number has 4 significant figures. Yeah, you're right. That's a good point. However, this is what people would expect you to write. But yeah, that's a good point. I hadn't thought about that. Thank you. Okay, cool. So, and yeah, if anybody else has questions, feel free to shout out or type in the chat or raise your hand, and hopefully Horatio will notice, because I've only got the chat open on my phone, so I can't see the other screen at the same time. So calculate the difference between two numbers. So this is something that actually comes up fairly frequently in numerical reasoning tests. So when we have to find the difference between two numbers, now if they're both positive, it's as simple as finding which one's bigger and which one's smaller, and then you just do the bigger one minus the smaller one. So 3.47 minus 0.68, and that will give you the answer. However, it's actually not that helpful to think of numbers in terms of using the words bigger and smaller, because when one is positive and the other is negative, actually these are all quite bad examples, but I think I put an example in the notes. Yeah, -8 or 3, which is bigger. So some people would say, well, 3 is bigger because it's like a higher number, and other people would say, well, -8 is bigger because it's bigger in size. So it becomes a bit ambiguous. So instead, we should think in terms of more positive and more negative, because then that removes any ambiguity. So in the first example, 3.47 and 0.68. So you just imagine a number line, or you could even draw one if you want to, and just place them on that number line, and which one is closer to if we keep going in this direction, we get to infinity If we keep going in this direction, we get to minus infinity. So you could think of it as which one is closer to infinity and which one is closer to minus infinity. So if we place those numbers on the number line, we can see that 3.47 is the more positive number and 0.68 is the more negative number. Now, obviously, in this case, you could just think of it which one's bigger and which one's smaller, but I'm just saying it's more useful to think in this way so that when you get negative numbers, it doesn't trip you up. So 42 is off over here somewhere, minus 53 is over here, so 42 is more positive, minus 53 is more negative. And when they're both negative, again, this is when it really becomes a helpful way to think of it. So minus 6.67 is more negative, and minus 4.32 is more positive. So what we want to do is take the more positive number minus the more negative number. So oh yeah, I'm going to do it on the calculator. That's why I put that slide in. Okay, so in this case, 3.47 minus 0.68 will give us 2.79. And then the next one, we would do I'm not actually going to type it in just to save time, but we'll do 42 minus 53. In fact, I will type it in. So 42 minus 53 gives you 95, which is the difference. Now, you might know that actually minus is just a plus. So instead of subtracting minus 53, we can just add 53. And we get the same answer. So that is a slightly quicker way to do it. And in this case, we have minus 4.32. And then we could either do minus 6.67, or we can just do plus 6.67, which is the quicker way of doing the same thing. And we get 2.35. Now, the difference between two numbers is always positive, because it's just what is the size of the difference. So even if they're both negative or whatever, it should always you should always get a positive difference. If you get a negative difference, the most likely explanation is that you just did the subtraction the wrong way around. You did the more negative number minus the more positive number. If that is what you did, then the answer you got is actually just the negative of the correct answer. So let's take the first example, 3.47 and 0.68. So if we accidentally did it the wrong way around, we did 0.68 minus 3.47, we get minus 2.79. The correct answer is 2.79. So if you realize, oh, I know what I've done wrong, I've just subtracted it the wrong way around, and you're certain that that is what you've done wrong, then you can just, you know what the answer is because you just drop the minus sign. It's just 2.79. Obviously, you have to be certain that that is what's gone wrong and not something else. Okay, so last thing on numbers, and then we'll move on to fractions. Some of these skills, by the way, are quite wordy because I've just written them in a very specific way, so it's really specifies the skill. But hopefully, even if it's unhelpfully wordy, once you actually read the notes or indeed listen to me explain it, hopefully it will be straightforward. So given the amount of some resource available and the amount of resource needed to obtain one item, find the number of items that can be obtained. So this is the kind of thing here. So the cost of one biology textbook is £17.99. The biology department of a school has £2,500 to spend on textbooks. How many textbooks can the biology department purchase? Or Jerry is inviting some friends round for dinner. He has 1,000 grams of pasta. He wants to cook 90 grams per person. How many people can Jerry make pasta for? So this kind of thing, yeah, it does come up quite a bit as well. Obviously, when I say these things come up, I mean it's one skill you have to use in a question that might require 3 or 4 different skills. So it's pretty straightforward, actually. You just do a division, but you just have to bear in mind that in most of these situations, your answer has to be the biggest whole number of items that you can obtain. So in this example, well, let's just do the calculation first. So we want the amount of money we have available divided by the cost of one book. So 2,500 divided by 17.99. And that gives us 138.966. Now, obviously, you can't buy 0.966 of a textbook. You can only buy a whole number of textbooks. So the number that you can actually afford, or that the school can actually afford, is 138. So the key thing here is that we don't round this number, because if we rounded it, we would get 139. But we can't afford 139 textbooks. We can only afford 138. So in other words, you always round it down, or you don't round it. In fact, you just chop off everything after the decimal point. And then Jerry's pasta. So we've got 1,000 grams, and it takes 90 grams to cook for one person. So we get 11.1 recurring. So that means he can cook for 11 people. Okay, cool. So we are going to move on to fractions. So if you haven't already, open up this fractions notes, and there is quite a bit in this, and it's a bit more difficult, but I'm still going to go through it fairly quickly because there's quite a lot to get through. And it would be good to get feedback maybe at the end on if you're finding these webinars too fast, too slow, or just about right. Okay, so enter a given fraction into calculator. Okay, so basically, the reason that I've put this in is that something that I've noticed when teaching maths is, like in person, is that a lot of people use the fraction button on the calculator whenever they want to enter a fraction. And a lot of the time, that is a lot slower than just doing it as a division. I'll show you some examples. Now, in an A-level or GCSE exam, that is not really that important, because most of the time it's kind of the thinking and the writing out your working. But in a numerical reasoning test, that is actually quite important, because obviously it's very time pressured. Okay, so unfortunately, this online calculator doesn't really handle fractions very well, but I found another one which does. So most, in fact, let me get this up. So most calculators will have, well, any scientific calculator will have a fraction button, and it probably looks something like this, but it may not, depending on your calculator model. So make sure you find out where this button is on your calculator. Oh, sorry, yeah, I just saw that. Thank you. So I might have misspoke. I don't know what I said, but the correct answer is, so the question was, did I say 138.966 is rounding up or down? Where's it gone? Oh, it was that last question. So the answer is always rounded down, or in other words, it's not really rounded. It's just, so if we just go back, so we have £2,500. Each textbook costs £17.99. So the number of textbooks we can afford is 138.966. But we can't actually buy, you can't phone up the publisher and say, hello, I'd like to order 138.966 textbooks. They'll ask you, do you want to buy 138 or do you want to buy 139? The problem is we can't afford 139 textbooks. That would cost more than £2,500. So the biggest whole number that we can afford is 138. So in other words, just ignore everything after the decimal point. Even if it's a 9 or a 966, you just ignore it, because we can't afford 139. Does that answer your question? Do let me know if it's still unclear. Yes, okay, excellent. And please do ask questions because somebody else might be wondering the same thing as you. So it's really helpful to me to know if anything was confusing or unclear or somebody wants it repeated. Okay, so yes, find out where your fraction button is. Now, different calculators I've noticed work slightly differently. So my calculator, you have to press the fraction button, then you type in the top bit, which is called the numerator, and then you have to press right or down on the arrows, and then you type in the bottom number, the denominator, and that inputs the fraction. I have seen some people's calculators where you just type in the numerator, then press the fraction button, then type in the denominator. So either way, you will get the fraction 17 over 29. Now, this, obviously, the second one is a bit quicker. So if you have a calculator that works like that, that's obviously a slight advantage. However, regardless of which method it is or which approach your calculator uses, if you then want to do something like times 120, you have to exit this fraction, because if you just get to this point here and then just type times 120, it will put the times 120 onto the bottom, onto the denominator of the fraction. You've probably experienced this. It's quite annoying. So you have to tell the calculator, okay, I've finished typing in my fraction now, and you do that by pressing the right arrow, and then you times it by 120. So the point of all of this is that it actually is quite time consuming to type this in, like using the fraction button. So I would suggest that in most situations, it's actually quicker to ignore the fraction button and just use the division button, because a fraction is essentially a division. There's no real difference. 17 over 29 and 17 divided by 29 are really the same thing. There's no real difference. So if you just type in 17 divided by 29 on your scientific calculator and press equals, it will actually come up with the fraction 17 over 29, because that's what this means. In fact, you might notice this division symbol looks a lot like a fraction. So it does mean, so it does save time in situations like this, because you don't have to exit the fractions, all those little fiddly button presses. And also, the bottom bit of the calculator has all these nice big fat buttons that are all close together. And so if you only have to stick within that region of the calculator, I think that will save you time as well. But maybe try it both ways and see what you think. The only caveat is that sometimes you might need to put brackets around your fraction. In this situation, you don't, because the calculator, because division and multiplication are equal precedence in the order of operations, which we covered last time. See Syllabus Pack 1. The calculator will just work from left to right, which is what we want here. If in other situations, you might need to put brackets around your fraction. But anyway, yeah, that's just to show that it's quicker to do it this way. Okay, so find the simplest form of a given fraction. So you may sometimes need to express a fraction in its simplest form. Now, when you're doing maths without a calculator, this is quite a involved topic. There's a lot to learn. But when you're doing maths with a calculator, it's actually really easy, because you just type the fraction into your calculator and press equals, and the calculator will show you the simplest version. So if we type in 91 over 63, the calculator will simplify that to 13 over 9. If we type in the other fraction, which is 68 over 153, the calculator will simplify that to 4/9. So that's really easy. Okay, adding, subtracting, multiplying, or dividing two given fractions, again, is super easy to do on a calculator because you just put in the fractions, and so this first one we need to add, and we just calculate, and then we get the answer, 19/8. And again, you can also do this just using the division button. So 5 divided by 8 plus 7 divided by 4. And if you were doing this on your calculator, it would show you the answer as a fraction. And you don't need to use brackets for this addition because the divisions will both be done first. The only time when you do need to use brackets is when you're dividing two fractions. So I'm actually going to skip to question 4 because I don't think you need to watch me do all of these sums. Okay, it's going to do it like that. Obviously on your calculator it wouldn't look like this. And then we get the answer, which is 35/108. Now, if you're doing this one on the calculator, you do need to put your fractions in brackets because otherwise you've got 3 divisions which are all equal priority, and it would just work from left to right. But for adding 2 fractions, subtracting 1 fraction from another, or multiplying 2 fractions, you don't need to use brackets around the fractions when you're using the division button, only for dividing 2 fractions or dividing 1 fraction by another. For a more detailed discussion of that, see the notes, but I'm going to keep going. Yeah. Okay, so converting between fractions and decimals, again, very easy to do when you're allowed to use a calculator. So if we type in a fraction, the calculator will convert it automatically to a decimal. No, in fact, it won't on most calculators. You have to press this button. So most calculators, the default view is that it will show you a fraction. And so if you press this button, which is labeled S to D to S, it will convert between the two different views. Obviously, you need to figure out how to do this on your calculator. It might be different. You probably can find your calculator's instruction manual online if you just type in the model number, or ask somebody, or ask in the Slack, and we'll try and help you figure it out. But I imagine most of you probably have some kind of Casio that looks something like this. Okay. And so the other one, when we start with a decimal, the calculator will usually display that as a fraction. Okay, so converting between top-heavy fractions and mixed numbers. So if you look in the notes, I've actually got this all formatted properly. It's hard to kind of do it on slides. But this is meant to say 2 2/7. So in other words, like 2 2/7, like that. So anything. So basically, just for a quick explanation of top-heavy fractions versus mixed numbers. So a top-heavy fraction is a fraction where the numerator, which is the top number, is bigger than the denominator, the bottom number. So for example, 17/5, 17 is bigger than 5. So this is a top-heavy fraction. And top-heavy fractions are always, they have a value that is greater than 1. So if you type in 17/5 on your calculator and convert it to a decimal, you will see that is equal to 3.4, which is more than 1. Now we can also write this as a mixed number, and it happens that it is equal to 3 2/5. Now the reason for this is because 5/5 equals 1. And we've got 15/5, which is equal to 3. And then 2 more fifths. So that gives us 3 and 2/5. But you don't actually need to be able to do that because your calculator can do it for you. So, so if you know where the S to D button is, just written above that in yellow, it's got this thing showing a mixed number being converted to a top-heavy fraction. And the way you access that is by pressing Shift and then pressing the S to D button. Again, it may vary between calculators. So all you have to do is input your, so let's say 2 and 2/7. Oh, you also need to be able to type in 2 and 2/7 if that's what you want to do. So for that, you have to use, if you look above the fraction button, it's actually got a little representation of a mixed number. So if you press Shift and then the fraction button, you can actually get this to come up, and then you can type in 2 and then press right, and then 2 and then press right, and then press 7. However, you might have guessed that there's actually an easier way, which is to just type 2 plus 2 over 7, and your calculator will do that for you. And most calculators are set up to automatically display the answer as the output as a top-heavy fraction rather than a mixed number. So to convert between the two, you just use Shift and then this button here, and that will convert. So what I'm saying is, for the first question, you need to first input 2 and 2/7, which you can either do by using this function here, or by just typing in 2 plus 2 divided by 7. And then the calculator will display that as a top-heavy fraction, which is actually what we want in this case. If we wanted to display it as a mixed number, we can use this function here by pressing Shift and then this button here. Your calculator may be set up so that the default that it displays is a mixed number and not top-heavy, in which case, again, just use this function to switch between them. But you can change that in the settings. If you go on Shift and then on here, you get into setup. Okay, so then for the second one, we would just put in 14 over 3, which we could either do as a division or using the fraction button. And then again, we use this function here to change between the two. Okay, so just seeing, yeah, we've still got quite a bit left. Okay, so find a given fraction of a given amount. So what is 3/7 of 1261? Or what is 12/5 of 72? So the way to do this is just to multiply the fraction by the amount. So 3/7 of 1261 is actually the same thing as 3/7 times 1261. This calculator uses the dot for times for some reason. And that gives us 540.43, which is the answer. Now, again, you don't have to use the fraction button. You could just do 3 over 7 times 1261. No need for brackets in this case because it will just work from left to right since division and multiplication are equal priority. What is 12/5 of 72? So again, if we just clear this, 12 over 5 times 72, we get 172.8, which is the right answer. Or you could do it using the fraction button, 12/5 and then times 72. Now notice that the answer is bigger than the number we started with. That's because it's a top-heavy fraction, which has a value of more than 1. So in other words, we're timesing it by more than 1. Okay, so calculate what fraction a given amount is of another given amount. So, for example, what fraction of 567 is 49? Or what fraction of 81 is 153? What fraction is 150? What is 156 as a fraction of 276? Okay, so to do these questions, you just divide. So if you want to know what fraction is A of B, then you just need to divide A by B. So it'd be easier if I just show you an example. So question 1, we just need to do 14. Actually, this calculator will not do the job because it won't display fractions. But we just need to do 49 divided by 567, or in other words, 49 over 567 if you prefer. And we'll get the answer, which is 7 over 81. Now, it can be a little bit confusing which number to divide by which. And the one that goes at the bottom is the one that has of in front of it. So because we're asking what fraction of 567 is 49. So it's 49 parts out of 567 as the kind of total. So therefore that goes on the bottom. So second one, what fraction of 81 is 153? So the 81 is what we're looking for it to be a fraction of, so that goes on the bottom. So 153 over 81, and we get 17/9, which is a top-heavy fraction. What is 156 as a fraction of 276? So it's a fraction of 276, so that goes on the bottom. And we get 13 over 23. Okay, so given an amount and what fraction it is of another amount, calculate the other amount. Actually, I don't think we're going to be able to explain this one in 2 minutes. So, and I said we finish at 5:33. So let me just end by saying, please do use the website. We've got the syllabus and the question packs. The question packs, I've put together 5 questions for everything, for every skill. And the answers are at the bottom of the document. If you get one wrong or you get stuck, have a look at the answer. See if you can work backwards and understand why that's the answer. If you can't, come and ask on the Slack channel. And if you have any other questions during the week, or any feedback or any comments, either about the maths itself or about the course, then come and ask on there. So maybe what would be useful, just in the last minute, if you could just type in the chat any feedback, including constructive criticism, or just let me know, did you find it too fast or too slow? Just tell me now in the chat before we finish off, just because that will help.